Now, this is interesting because we've got another triangle that looks exactly the same. Actually, I literally copied and pasted the triangle, okay? So it is the same triangle, but what's the difference? Now we've got coordinates. Yeah. We've got coordinates. Now it's the same problem. So that means that all this logic that we used before, I can use it again. I just need to know how it applies to this coordinate geometry situation. Okay. So I'm still trying to work out this distance from A to B. That distance there. Okay. Now, being that that's the distance I'm after, when we used the previous question, to work out this distance, we used the other two. Can you see that? If you know these two, you can get to that one using Pythagoras. Is that okay? Mm-hmm. So I'm going to do the same thing here.
Oh, but you just have to find them.
Yeah, that's right. I need to know, okay, what's this distance, right? I'm going to have to work that out. And then I have to work out, well, what's this distance? In the previous question, they were 5 and 12, but I don't know what they are here. Right? So let's give this a go. Now, how do you go about working out this vertical distance?
10, 6,
okay, now, it's to do with rise over run, right? It looks just like that, doesn't it? Okay, you can see that it goes from, now this is 1, 1, isn't it? Okay, so rise is about the x or the y coordinate.
It's 6.
Y.
It's the y coordinate, which is 6, right? So you started from 1, right? That's the y coordinate
That's
here.
10.
And you go up to 6. That's what you're telling me. Okay? You went from 1 to 6. So the difference between 1 and 6 is 5, right? 6 minus 1 is 5. Okay? That's what this distance is. Okay? Another way of saying it, that's the rise. Okay? Does that make sense?
-1 too.
Say that again.
For the other one, is it 10 minus 1?
Okay, yeah, good. So we've moved past the rise, the vertical part here. I want to do the run, the horizontal part. Well, I've got to go from 1 all the way over to 10. You can see it's the horizontal part there. So 1 to 10, that's 10 minus 1. So that distance is going to be 9. Okay? So this is good. Now I have these two distances in here, right? I'm going to do the same thing I did before. I'm going to do Pythagoras. I might fit it underneath here. I think we'll have enough space. Okay. I'm going to write the hypotenuse squared is equal to, what's it equal to, guys?
6 squared plus 9 squared equals...
Whoa. 6? Where did 6 come from?
5.
I actually want this length. No, 5 and 9. Good. Yep.
Plus 9 squared.
So 5 squared plus 9 squared. There you go. That's Pythagoras' theorem.
Wait, where did you get the 10 from? Okay.
Yes, where did I get the 10 from? It's the coordinate there. It's provided there, that 10. Okay. So,
Is it 100?
yeah, okay, I haven't got there yet. You're getting ahead.
Wait.
So,
Wait,
yeah, question?
So it's like, okay, never mind. I think yeah.
Do you see it? It's okay, we're going to do a few more examples, you'll see. Alright, so we're going to get to the number now. 5 squared is 25, 9 squared is 81. So you add those together and it looks like 106. Okay. Now, this is a bit messier. Unfortunately, 106 is not a square number. Okay, but that's no big deal. All we have to do is write the square root of 106. That's it. That's all. And it's units. And don't forget, we only took the positive one because AB is a length. Okay, so since AB is a length or a distance, it has to be positive. Okay. Now, I think that's fine. We're finished. But just for the sake of curiosity, if you have your calculator there, let's just approximate this. What will we get at? 10.29. Great. 10.29.
So
that's 2 decimal places.
that's 10.8.
We'll just leave it as 10.29. I think that's fine. Okay. That's just so that we can say, well, how long is it? Does that look about right? I think it's fine.
Yeah.
Okay. All right. Good. So you've seen we moved from a regular triangle with Pythagoras. It's okay, I'm going to be back in a sec. Which you know. And then we looked and we saw the same kind of triangle, but when it's all in terms of coordinates. Okay? So when you want to find these distances, you've got to understand how to use the coordinates carefully. Okay? So, do you want to leave that there while you catch up with the writing?
Do we go to the next page and try ourselves?
So if you're finished writing this, you can turn over and have a look. For the rest of you, I'll give you another 30 seconds or so, and then I'll turn over. Question? About the next one? The first one? Yeah, what do you want to ask? You're going to have to wait if you want me to come over there. Or you can ask me now. Yeah.
If you just did like 106
like 6 square root. Like,
Yep.
Would that be right, or do you have to actually do like you actually have to find out?
Yeah, sure. Okay. So which one is your question, right? Which one?
Yeah.
And the answer is, look at the question. So if the question says nothing,
Isn't there only, don't they only mean
Yeah,
steps
that-
now?
that's what I said.
say that again.
Don't they only mean steps because it doesn't ask for anything?
Yeah. So if they don't say, right, then they don't. They if they want you to approximate, they have to tell you 1 decimal place, or 2 decimal places, or 3 significant figures, right? So you look at the question. If it doesn't say anything, just leave it.
Okay.
If they say approximate, that's when you go to the next line, and we've gone to 2. They might do 1 or whatever. So look at the question. Okay. Yeah, Lucas.
What are those squiggly lines underneath?
That means approximately equals.
Okay.
Approximately. Because it's not exactly, but it's pretty close.